Toshiba has introduced an automotive grade stepper motor driver for automobiles into the market. So it is into production. This is TB9120 AFTG. So we will talk in brief about some of the features of this chipset. So before going to that, let us just look at what a stepper motor is. Basically, a stepper motor is mainly used in some of the applications like robotics, and then some of the speed measurement related applications where you don't need that high speed but you require that holding torque, which is very important. So in such applications we see stepper motor being used. So the one important functionality is that the shaft which is connected to this stepper motor you see here will see a step change in the output, which is very important for some of the critical applications like robotics. So if you see the functionality of this construction of this stepper motor and its functionality, so it will have a stator and a rotor, where the stator is supplied is wound with a coil which is supplied with a power supply. And this based on the stator to which this supply is provided, the rotor gets aligned to that particular point, which is called a phase. So basically each stator can be called a phase. So now this rotor could be a simple magnet, a permanent magnet basically, or it could be a variable reluctance coil. So this permanent magnet and variable reluctance coil have their different advantages and disadvantages, so which is like we can talk later, but these two are options which we have, and there is also hybrid option which combines the capabilities of this magnet and reluctance coil. So now if you see this motor, when we say we are going to drive the stator, the controller, when we say controller, it's a microcontroller, cannot drive the stepper motor directly because the microcontroller generally will have 3.3 volts or worst case of 5 volts with a supply output of maximum 10 milliamps. So in this case it cannot drive the stepper motor directly. To drive the stepper motor we need a driver IC which provides the required supply and current to this stepper motors. So generally we will have a 12 volts operated or 9 volts operated devices, which is a nominal voltage basically, or the typical value we say, which can be provided by this driver. So this driver could be basically a FET based or it could be a BJT phased. So some of the examples of these driver are ULN2003 and L293D. ULN003 is one of the common drivers used across the industry for this application. So now talking about this ULN2003. So this is one of the common chipset where from a beginner to a professional uses this for different applications where you will have a Darlington pair based circuit which drives the output with input from the microcontroller. So this can supply up to 500 milliamps against each section. So this has around 7 sections, we should say pairs basically, the input output pairs, and this is how the circuit looks like. So this is one of the simple driver available in the market. Now in addition to these capabilities, there are some requirements, like you should be able to detect the temperature, you should be able to detect the over voltage or over current related function conditions to protect your motor. So A4988 is one more driver. So one important point before going to this, UL2003 does a single step at a time. It doesn't have microstepping. When we say microstepping, it is like fraction of a step. Stepper motor is nothing but it just produce output in steps, right? So a fraction of a step can also be achieved using device like A4988. Along with this fraction of steps, this particular driver, as you see here, can also do microstepping. So it could be a full, it could be half, 1/4, 1/8 and 1/16, and it has thermal shutdown, shorted load condition, and crossover current protection. So there are many functionalities which are associated with this driver. So this driver you see here can be controlled by a microcontroller logic to define the steps, whether it be full, half, or any other related functionality, and this further controls the motor. This is a simple block diagram which shows the functionality. So this is how the internal block diagram looks like, where there is a H bridge controlling each phase of this stepper motor, and now this particular chip, if you see, operates in the range of -20 to 85 degrees centigrade, and is not automotive qualified, and also it doesn't have stalling related functionality. Now Toshiba has introduced something called TB9120AFTG, which is again a stepper motor driver, which is specifically for the automobile applications. You can see here this is released this July 2020, and right now it is in production. So this particular chipset, if you see the data sheet, so it is basically a QFN based automobile chipset, and it is a constant current two-phase stepping motor. So it can control two phases, and then this is AEC Q100 qualified, which is critical for automotive applications. And then we also know that stepper motor is one of the critical application of stepper motor is the automobile industry, right? So microstep drive also can be done, like it might be full till 1/32 can be done, which is PWM based control internally. And then it has a stall detection function as well. Stall detection function basically provides a stall pin output on a pin, which can be used to control other functionalities. This is how the internal block diagram of the chipset looks like, which is a TB9120AFTG. So if you see here, basically the H bridge controls the two phases, and then there is a stall detection. There are other controls which can be connected to a microcontroller and used. So it can work standalone, or you can use an external microcontroller to control this chipset. Now if you see the product specifications, as we said, there is a constant current PWM control, and the excitation could be full step, or it can be up to 1/32 steps. It is a single chip two-phase stepping motor, and you can see the on resistance of the MOSFET, H bridge MOSFETs inside, and it can support up to 1.5 amps, which is absolute maximum rating. And it has stall detection, thermal shutdown for temperature, stall for motor sudden stalling, where you can where sudden current shall be drawn, so that condition can be detected, and then overcurrent detection is there, and open load condition can also be detected. And it can operate 7 to 18 volts, which covers the 9 volts and the 12 volts, which is covered by most of the stepper motors in the market. And then it can operate up to -40 to 125, which covers the automotive supply, and it mainly it is AEC Q100 qualified, which is the major feature of this chipset. And then if you see, this is a simple block diagram, so you can use external MCU and then control this, or you can use the standalone by providing the straps that are required to these pins. So we can say a good chip in the market for automobile applications, AEC qualified chipset. Try it out for your applications and observe the functionality. Thank you.